Okay, I didn't really know what to do, so I think I'm just going to go through the resource packet and highlight stuff you got to know. So first things first, let's talk about finding percentiles. So, let's see, I have the test on another monitor, and so I'm kind of looking to see what's important. Okay, so to find the 20th percentile, right? So in this exact problem, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there are 20 complete numbers of data. So if I want to find I'll use this as like a little whiteboard or something. Little whiteboard, resource packet. Okay, so if I wanted to find the 20th percentile, so that means I'm looking at 0.2, that's the percentile as a decimal. I'm going to multiply it times my number of data, 20, and this would give me 4. So that means that there are 4 numbers less than the 20th percentile. So that means I would count to the 5th number, which would be 1, 2, 3, 4, 5, 75. 75 would be my 20th percentile. So if I wanted to find, let's say, my 45th percentile, that'd be 0.45 times the number of data in our set, 20, and we end up with a 9. That means there's 9 numbers below our 45th percentile. So we have to count to the number 10 to find it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 80 would be our 45th percentile. Okay. Pretty much all you need to know there. You got to know your z-score formula. That's really important. Okay. Calculate and interpret z-scores. So in this problem, we calculated and interpreted the standardized score for Ohio, and we got 0.751, because it's just the value minus the mean divided by the standard deviation. And then you have to say in context. So the number of representatives for the state of Ohio is 0.751 standard deviations above the mean. Remember, if it's a negative value, it would be below the mean. And the mean number of representatives for all 50 states. So in this problem, we're calculating Ohio's counties, and we're comparing them. So Ohio is further from the mean in the distribution of representatives than in the distribution of counties because the z-score is greater. So that's how you would justify something being better, faster, bigger, is having a bigger z-score. Okay. Let's see, is this mentioned too much? Doesn't look like it. Yeah. So shape. So if everything is likely to happen, like equally likely to happen, that would be a uniform distribution right here. So uniform distribution is a box. Remember, the area under the curve is always 1. So if this distance, let's say, was from 0 to 20, then this number, 1 over k, would have to be 1 over 20. If this first number was a 5 and this number over here was a 15, that means that the bottom of the rectangle has a base of 10, and this height would have to be 1 over 10. Okay. When it comes to the shapes, skewed right, if it is skewed right, that means the mean is greater than the median. And if it's skewed left, that means the mean is less than the median. Okay. The mode is the number that happens at the peak. The median's always between the mean and the mode, and then the mean is always the one that's furthest towards the tail. And don't forget, when you do a normal curve, to include the n notation over here. The n with a mean and a standard deviation. That's super important. Okay. Sorry, it looked like my little baby was starting to move. See? Look at her. Oh, how cute. She has a little helmet because her head's crooked. Okay. A big part of your test has to deal with these z-scores and calculating z-scores. So we have the empirical rule, which is pretty important. And we need to know the 68, 95, 99.7 rule. And you need to know what each of these is worth. So the empirical rule will be given to you. We'll make sure Miss G broadcasts that. But you need to know how to place the numbers along the bottom. You guys are all pretty good at doing that. This one is worth a lot of points. So trying to say if the distribution is approximately normal. So you need to do a bell curve, similar to how they did up here with the curve. Let's go ahead and zoom in. And then you have to do the 68 is between 1 standard deviation, 95 is within 2, and 99.7 is within 3. So like in this particular problem right here, we would have to figure out how many numbers in our data set were between 1 standard deviation. In this particular problem, 24 of those numbers were within those boundaries, and that gave you 66.7, which is about 1.3% away, so that's fine. The boundaries for 2 standard deviations are right here in the middle, and it turns out 34 out of the 36 numbers in our data set fell within there. Where did this data go? Is it because I zoomed in too much? It's weird. Was it in the original? No. It's weird. 14.68. And then you have your boundaries for your 3 standard deviations. And it turns out all of the data was in there. So 36 divided by 36 came out to 100%. Okay, so just like the practice test and just like the review problem, you need to know how to set up these boundaries and count how much of your data percentage-wise is in there and compare them to the 68, 95, 99.7 rule. Okay. Again, you got to know how to set up this curve. Don't forget the n, normal, mean, standard deviation. Calculating your z-score. You gotta know this formula by heart. So depending on what you're asking you for, if it's asking you for a percent, that means you need to find the z-score first and then convert using table A. If it's asking you for a proportion, again, you start by calculating the z-score, use table A, give the proportion. Now, if it tells you a percentile, for example, in this problem, and you're trying to find the percentile, you need to use the percentile number 0.20 and find 0.20 within table A and figure out which z-score matches that percentile score. Okay. You plug that in for z. If you know your mean and you know your standard deviation, you work your way backwards to solve for x. Or sometimes you work your way backwards to solve for the average. Sometimes you work your way backwards to solve standard deviation. But this is going from a percent back to a z-score. So that's really important to keep in mind. Also remember, take into consideration that table A only does area to the left. So if table A only does area to the left, you got to be really careful for these words. So, for example, when you run into problems like this, which says 8.9% of teen girls have high cholesterol that is levels of 200 milligrams or greater. So because it says or greater, that means this shaded area is the 8.9%. However, table A only does area to the left. So we're going to subtract that 8.9% from 100, which is 91.1%. And then you have to look within table A to find out what z value corresponds with 0.911, or the closest number to 0.911. So looking in table A, that gives you a value of 1.35. We knew our value of high cholesterol. We knew our mean, and we just have to solve backwards to find the standard deviation. Okay. The practice test and the review are really, really good tools. So I'm going to let Miss G let you guys work together for like 10 minutes to review as much as you need to, and she's going to hand out the test. Best of luck to you guys. Sorry I couldn't be there. And yeah, good luck. You guys got it.